let's learn about the isosceles triangle. Basically, we have two major features of an isosceles triangle. These types of triangles have two equal sides and they also have two equal angles. Now, if we take a look at the basic structure of an isosceles triangle, the two equal sides are these two here. Okay, they're basically located across from each other when you stand the triangle up. And then the angles that are equal are the angles at the bottom or at the base of these two sides. Okay, so that's the basic features of an isosceles triangle. So now look at some of the applications of this type of triangle. Okay, isosceles triangles originally were used in what was called building an A-frame house. So basically the house was made of a series of triangles and the basic frame was made out of wood. So we'll just take a look at what that looks like. Okay, so here's kind of what it would look like. It was basically just a series of isosceles triangles, basically forming the structure of the actual house itself. Nowadays, modern isosceles or modern buildings don't have what's called a pure isosceles triangle. They actually just incorporate triangles, isosceles triangles, in their frame. So these two are examples, and you see that this is like basically a version of the old A-frame style of cottage or house, and it just has a little more complicated structure. Okay, so if you take a look at the frame here, if you take the photo and you put it into what's called Geometry Sketchpad, which is a graphing program, you can actually take a look at some of the features, which we'll do. You want to do is you want to do some measurements. Now, these squares actually represent centimeters. So everything that our measurements are going to be in centimeters, but that's okay because it's basically just like a scale diagram. So click on the line tool and then just draw a line. Okay, so that will be one side there, and then draw another line going down here, and that will be two sides. And these two sides should be equal if this is a true isosceles triangle. So you highlight them by clicking on them, and then you just go measure length. Okay, and you can see there. They're both 8.6 centimeters. Okay, so and going across the bottom, you can see that this is not an equilateral triangle, which means all three sides are the exact same length. Because if you count up the centimeters on the bottom, 1, 2, 3, 4, 5, 6, 7, 8, the bottom is only 8 centimeters across. Okay. So the other feature that we want to look at is the angles. And if you take a look here, we know that if the two sides are equal on the left and the right, then we know the angles at the bottom are also equal. So basically what that means is this angle here, okay, is also equal to this angle over here on this side. Okay. So now what's interesting about an A-frame building is that the way that the frame was originally built is you would sometimes have two floor homes. Okay, so you might have a single floor, but in a lot of these cases they were actually two-floor houses. So the second floor, as you can see by the photos, is about here. Okay, so the way that it works is that this angle here, as soon as you put a second floor in, this angle that I'm drawing in now is actually the same as this angle. Okay, and because this angle is the same as this one, it means that this angle here on this side, okay, is also equal. Okay, so when you connect these two, you'll find that if you went and measured them with the protractor, you would find that they're all equal angles. Okay, so these four angles are all equal. Now in this case, this A-frame house also has a very small attic up here. Okay, and the actual same theory applies. The angle at the attic is also equal. Okay, so because the angles on the second floor and the first floor are all equal, then actually this angle as well, the angles of the attic are also equal. Okay, so I'll just reposition the photo and then add the line. Okay, so what's interesting about the isosceles triangle and the A-frame building is that if both the angles at the base are the same, then the angles at the base of the second floor are also the same, and then the angles at the base of the attic are also the same. Okay, so all 6 of these angles are also the same. Okay, so that concludes our look at the isosceles triangle and its applications.